You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. This episode explores the foundational control structures that drive how computer programs operate: sequence, branching, and looping. These terms define the way code is executed, either by moving straight through a set of steps, making decisions based on conditions, or repeating actions until a condition is met. You will not be expected to write code using these structures on the Information Technology Fundamentals Plus exam, but you must understand what they mean, how they behave, and how to recognize them in descriptions or diagrams. These three concepts, sequence, branching, and loops, are found in Domain 4 of the Information Technology Fundamentals Plus exam, specifically under Logic and Structure. The exam focuses on a conceptual understanding of flow control. You may be asked to identify which type of logic is being described, or to match a programming behavior to the correct control structure. The exam will not include code syntax or complex logic paths. Your job is to know the difference between the three and understand how they shape program behavior. Sequence in programming refers to a set of instructions that are executed in the exact order they appear in the code. There are no decisions or repeated actions in a sequence. It represents the simplest type of program flow and forms the default structure for all programs. Each instruction leads to the next without interruption. Even in complex programs, the default behavior is to follow sequence unless altered by other structures. This is the basic flow every program starts with before additional logic is introduced. Examples of sequence can be seen in tasks like printing a message, receiving user input, and calculating a result. In such a case, each line of code runs one after the other, without branching or repeating. For instance, a simple program might first print, "Enter your name," then wait for input, and finally display a greeting. All of this happens in order, with each step executed once. These types of tasks show the core of what sequence looks like in action. One step leads directly to the next. Branching is a control structure that allows programs to make decisions based on conditions. It evaluates a logical test and chooses different paths depending on the result. This is commonly done using statements like if, and else. In branching, the program asks a question, and based on whether the answer is true or false, it performs one action or another. This allows for flexible decision-making in code and is essential for programs that must behave differently in different situations. Examples of branching include logic like, if age is greater than 18, allow access, or if password is incorrect, show error message. Each of these decisions guides what the program does next. The condition determines the direction of the code flow. When a condition is true, one path is followed. When false, a different path is taken. These branching actions help tailor program behavior to real-world situations and user inputs. Boolean values are central to branching. These values are either true or false and are used to test the conditions that drive decision-making in code. When a program reaches a branching statement, it checks the condition. If the result is true, one block of code runs. If the result is false, another block may run instead. This use of Boolean logic underpins all conditional structures in programming. The exam may ask you to identify whether a statement represents a Boolean-based decision. Looping is another core structure in programming. Loops allow a program to repeat a set of actions multiple times until a condition becomes false. They are used when the same task must be performed over and over again. Loops help reduce repetitive code and allow for dynamic behavior, such as processing all items in a list or checking for a condition at regular intervals. There are different types of loops, but they all follow this same general principle of repetition based on a condition. Examples of loop behavior include statements like, repeat while balance is greater than 0, or for each item in a shopping cart, display its price. These examples show how loops run actions until a particular condition no longer applies. Once the condition becomes false, the loop ends. and the program moves on to the next section of code. Loops are extremely common and form a key part of most software applications, even those with very simple tasks. There are several types of loops used in programming. A while loop runs as long as a condition remains true. A for loop repeats a specific number of times, often based on a counter. A do-while loop performs the task once before checking the condition, which ensures that the loop runs at least one time. While the Information Technology Fundamentals Plus exam will not test these in depth, you should be able to recognize that each type of loop is used for repetition and that the loop's continuation depends on a condition. Loops and branching often work together in code. For example, inside a loop, you might find an if statement that decides whether to continue, skip an item, or stop entirely. In other cases, a loop might contain multiple conditions that affect how it behaves during each cycle. Branching allows a program to make decisions inside the loop, while the loop handles repetition. The exam may describe a scenario where both are present and ask you to recognize how they interact to shape the program's flow. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Each of the three control structures, sequence, branching, and looping, plays a different role in determining how a program flows from one instruction to the next. Sequence moves in a straight line, executing each step in order. Branching introduces decisions, allowing the code to take one of several possible paths. Looping enables repetition, running a set of instructions again and again until a condition changes. Understanding how these structures affect code flow helps you recognize program behavior even without writing the code yourself. When you see a description of a program's logic, being able to recognize which control structure is being used is a common test objective on the Information Technology Fundamentals Plus exam. If the description says, check a condition and go one way or another, you are looking at branching. If it says repeat until finished, you are seeing a loop. If it describes step-by-step instructions in a fixed order, then it is referring to sequence. Each of these clues helps you identify the correct structure without needing code examples. These ideas also connect to real-world logic examples. Imagine an ATM machine. It begins by checking your card and balance, then proceeds with your withdrawal, and may repeat these steps until you end the session. That behavior represents a combination of sequence and looping, with branching used to verify account status. Another example is a login form. If the password is correct, the system grants access. If not, it displays an error. This is branching in action. Cooking instructions also follow this structure. You follow steps in order, make decisions about ingredients, and sometimes repeat steps like stirring or baking for a set time. Flowchart symbols often represent these structures visually, helping you analyze logic without reading code. A rectangle represents an action, such as displaying a message or performing a calculation. A diamond shape represents a decision, like a conditional check in branching. Arrows connect the shapes and show the direction of flow. These symbols are not required knowledge for writing flowcharts on the exam, but you may be asked to identify them or understand what kind of logic they are describing. Understanding the terminology associated with control structures can also help you on the exam. Common terms include condition, which refers to the test being evaluated, and loop, which refers to the structure repeating an action. Other terms like if, else, and repeat are directly tied to how decisions and loops are described. Words such as sequence, Boolean, and execute may appear in questions and need to be matched with the correct concept. Memorizing these terms and knowing what they mean will prepare you for this section of the exam. The exam questions related to control structures typically come in three formats. One style asks you to match a term like loop or sequence to its definition. Another type presents a description of a process and asks you to choose which structure is being used. A third type may show a visual diagram or short chart and ask you to identify whether it represents sequence, branching, or looping. You will not need to write any code or follow nested logic, The questions focus purely on recognition and understanding. There are a few things that the exam does not include. You will not need to understand the specific syntax of control structures, such as how to use brackets or parentheses in a programming language. You will not be tested on nested structures, where one loop or branch is placed inside another. The exam does not expect you to perform detailed analysis. Instead, it focuses on identifying the type of structure and understanding how that structure affects code flow. Some of the most important terms to remember for this episode are sequence, branching, loop, and condition. You should also be familiar with the terms true and false, as they are part of Boolean logic. Repetition refers to the behavior of a loop, and decision refers to the logic found in branching. These terms are commonly used in both programming and exam questions. Being able to define them clearly and recognize them in context will give you a solid advantage on the test. This episode also builds on knowledge from previous episodes. We have discussed data types, Boolean logic, and the use of flowcharts to visualize logic. All of those topics come together in the discussion of sequence, branching, and looping. These control structures are essential to every program, no matter what programming language is used. They allow logic to be implemented in a structured and understandable way. By using these tools, programmers create software that behaves in a predictable, controlled manner. To summarize the control structures we have discussed, sequence is the default behavior where code runs one line at a time. Branching introduces decisions, allowing a program to change direction based on true or false conditions. Looping allows repetition, so that actions can be performed multiple times. Together, these structures define how programs operate logically. Recognizing these patterns will help you not only on the Information Technology Fundamentals Plus exam, but also in understanding how real software works behind the scenes. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.